We're doing a test with hop oil. After we weigh in the hop oil, we're going to record the time for the first drop to appear in the topside glass, the first drop to appear in the distillate, and the first drop to appear in the residue. We're running the entire test at a feed rate of 2.5 liters an hour. That is a slow feed rate. That's just so that we can make the test last longer so that we can do more samples.
So our overall goal is to get a 35% yield out of this hop oil.
We took our first sample, we're about to collect our second. There's been a couple major changes to the test plan because the material is much more volatile than we expected. We actually have a very large cold trap fraction. And the distillate's very runny. So we're running the distillate pump quite fast to get it to discharge, but it is discharging just fine. We're already at a 30% yield according to the ratio of the feed pump to the residue pump. That's about 70%, so we should be getting 30% yield or about 29% yield. But that is split between the distillate outlet and the cold trap.
So the differences that I have seen from cannabis oil distillation to hop oil distillation, namely the temperatures that we distill at, we're distilling at around 103 right now. Probably the max temp that we're gonna go up to is 120 Celsius. The final product is very, very thin. If this is like as thin as what you would expect to see in a cannabis distillation in the cold trap, we do have a pretty full cold trap as well. And then the residue is not as dark and it does not smell as bad as cannabis oil distillation residue. We have a lot more different scents in here. There's the ester scent. I can smell esters in here and I never could smell esters in cannabis oil. And esters have like this pineapple-y fruity scent. So that's really interesting to me.
It's observed that the odor profile of the distillate has changed. And there's actually two possible reasons for it because we did change two variables. We've been increasing the evaporator temperature steadily, so a heavier compound could be distilling now because we have a higher evaporator temperature, but we also decreased the condenser temperature, and that was in an effort to try to unload the cold trap and keep the vacuum stable. So that means we could also be condensing a lighter weight compound, which was previously going to the cold trap.
So we're wrapping up right now. And we've gone over a wide range of temperatures, all the way from 90 C up to now 135 C. This is what the crude looked like when we started. And this is the distillate. And we haven't actually seen a whole lot of changes over that temperature range.
Yeah, so as we ramped from 90 to about 101 Celsius, we started with an initial yield of about 25%, and we got to a yield of about 31%. But since 101 Celsius all the way to 135, like 34-degree temperature range, the yield percentage has been exactly the same. I expect that the yield percent will actually stay the same as we increase the feed rate. Hopefully up to, well, until we run out of material, we'll find out.